Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to wrap up our first chapter by learning how to simplify algebraic expressions, okay? Now, when working with algebraic expressions, well, with any expressions and equations, it is really important to know the following vocabulary that I'm going to be very specific about. I'm going to teach it, but the only way to learn this is to really just pay attention, write down not only the definitions, but I'm going to give explanations, so write keywords for yourself to help you remember. If I am talking faster than you can write, please remember that you can always pause this video. Okay, so let's talk. Let's do it. A quantity. Sounds simple enough, but what is a quantity? Well, a mathematical quantity is anything that can be measured or counted. Some quantities remain the same. These are called constants. Some quantities vary. These are called variables. So anything that can be measured or counted is a quantity. So I had 5 slices of pizza. 5 slices is a quantity. The millionaire owned 7 different types of Bugattis. That's a quantity. The baseball player hit 12 home runs. That's a quantity. Anything that can be counted or measured. Number 2, a variable. A variable is a symbol, usually a letter, okay? Usually a letter. Popular variables are n and x. That's why we do not use x for multiplication any longer. So it is a variable is a symbol, usually a letter, that represents the value of a quantity. Okay, we've already talked about evaluating before. That's when they give you an expression and they give you a value for the variable in the expression. Okay, that value pertains to that variable because that is what a variable is. It is a symbol used to represent a value. So if I say x plus 4, I want you to calculate this when x equals -7. Well, then this x is -7. I plug that in, so that's -7 plus 4. I know this is simple enough, but what I'm trying to really bring home for you is that the variable is this x. And in this particular case, the x equaled -7. That doesn't mean that x is always going to equal -7 every time you see x. X is variable, okay? It can mean anything. It can represent any number. A numerical expression, okay? Pretty simple. A numerical, oh, sorry about that. A numerical expression is a mathematical phrase or sentence involving numbers and operation symbols, but no variables, okay? So 5 plus 9 plus 8 plus 12 plus 1/3, that's a numerical expression. An algebraic expression is a numerical expression which includes one or more variables, okay? So a numerical expression could be 5 plus 8 plus 3/5. That's numerical, right? Okay, but an algebraic would be 5 plus 8x plus 7, okay? Now that it has a variable, it's now called an algebraic or variable expression. Okay, number 5, a term. Very important, probably the most important vocabulary word of the day. And a term is an expression that is a number, a variable, or the product of a number and one or more variables. So a term is a number like 8, a variable like y, or the product of a number and one or more variables like 5x or -7xyz squared. Okay, all of those are terms. It's a number, a variable, or the product of numbers or variables. Very, 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 very important. Very important. Coefficient. Okay, the coefficient is the numerical factor of a term. Basically, it is the number being multiplied to a variable. So in other words, it's the number in front of the variable. If I have 7x, 7 is my coefficient. If I have negative 3x, negative 3 is my coefficient. If I have negative 2yz, negative 2 is my coefficient. If I have 8x plus 3y minus 5w, 8 is a coefficient, positive 3 is a coefficient, and negative 5 is a coefficient. A coefficient is the number in front of the variable, the number being multiplied to a variable. The coefficient could be a fraction or a whole number. Constant. Okay. Think about the word constant. When it's constantly raining outside. Okay? Give me 1 second, please. Sorry about that. Okay, let me erase this here a little bit. Constant term. A term with no variables. Okay, it's just numbers. So a constant term, remember, it is a term. A term can be a number, variable, or the product of numbers and variables. When it's just a number alone by itself, it's a constant term. So 9 is a constant term. 136 is a constant term. 3/8 is a constant term. So a constant term is a term with no variables. It's just numbers. Okay? Only numbers. Like terms. Okay. Like terms are terms that have the same variable raised to the same power. All terms can be multiplied, but only like terms can be added or subtracted. Think about going to the store. If you purchase 3 apples, and then your sister also, or your brother, a friend, purchases 3 bananas. Do you guys have 6 apples now? No. Do you have 6 bananas now? No. You have 3 apples and 3 bananas. You can only add apples to apples and bananas to bananas. Now, if you go get 3 apples and your friend goes and gets 3 apples, now you have 6 apples in total because they are like terms. Okay? So like terms are terms that have the same variable raised to the same power. All terms can be multiplied, but only like terms can be added and subtracted. So for example, 7x squared plus 2x squared. These are like terms because I have the same variable x and I have the same exponent 2. So in total there are 9x squareds. Think of the variable part of the term as a type of item, okay? And only the same items can be added together. Okay, now let's identify the terms, the coefficients, the constants, the like terms, if any, for each algebraic expression. All right, let's do this. Sorry about that. Okay, we're back. So for number 1, we have negative 4ax plus 7x minus 6ax plus 4. I want to identify the terms, the coefficients, the constants, and the like terms, if any. I'm not asked to simplify this. If I was asked to simplify, then I have to add like terms. Right here, I just want to identify. So let's do it. Okay, let's look at A. A are the terms. Okay, the terms here are negative 4ax, comma, positive 7x, comma, negative 6ax, and positive 4. All of those are terms. There are 4 terms here. Okay, remember terms are numbers, variables, or the product of numbers and or variables. Let me go ahead and move this a little bit down so we could have more space. And this is actually example 1. Okay, so let's get to it. B, we're asking for coefficients. All right, so my coefficients here, the number being multiplied to the variable, the number in front of the variable. So I got negative 4, a 7, and a negative 6. How about the 4, Mr. Morrow? Nope, that's not in front of a variable, so it is not a coefficient. C, The constant. Ah, that's where the 4 comes in. That's the constant. And D, the like terms. My like terms. Okay, well, I got a negative 4ax, and I got a negative 6ax. They both have the same variables, raised to the same power. So negative 4ax and negative 6ax are like terms. How about the 7x? No. You do have an x, but you're missing an a, so that's not a like term. And you don't have any other terms with an x, so you're done. Okay, number 2. We got 3x squared plus 5x squared plus 9y cubed z plus 2yz minus 4y cubed z. A. Let's list the terms. So I've got 3x squared, 5x squared, 9y cubed z, 2yz, and a negative 4y cubed z. B. Let's list the coefficients. These are the numbers being multiplied to the variables. So I've got a 3, 5, a 9, a 2, and a negative 4. C, the constants. Well, there are no constants. There are no terms here without a variable. There are no terms here with just numbers. And D, the like terms. Okay, so D, the like terms, you've got 3x squared and 5x squared. That's one set of like terms. And then I have 9y cubed z and negative 4y cubed z. The 2yz is not a like term to any other terms here because it does have the y and the z, but it does not have y cubed, so that is why it is not included as a like term. Okay, number 3. Our terms here are A is 8x. I got a negative 3y. Remember that a negative times a negative is a positive. Okay, so that's a positive 6x and a 5. Those are my terms. My coefficients. My coefficients are 8, negative 3, positive 6. My constants are 5, and my like terms are simply 8x and 6x. Okay, number 4. My terms. I got 2x squared, a negative 8y cubed, and a negative 6x squared. B, my coefficients. I've got a 2, a negative 8, and a negative 6. C, my constants, none. There are no terms here without variables. There are no terms here that are just numbers alone. And D, my like terms, are 2x squared and negative 6x squared. Y cubed is not a like term because it has a different letter, it has a different variable, and different exponents. All right, let's continue now because it's just a matter of applying all of these vocabulary words that we learned. Okay, this is actually example 2. Evaluate each variable expression. Okay, let's evaluate each variable expression. Remember that when we're evaluating, they give you the value of a variable, and you have to plug it in and then use order of operations to solve. So in this particular expression, they're telling you you have 7 times a plus 4 plus 3b minus 8 for a equals negative 4 and b equals 5. Let's go ahead and just plug it in and then just solve and evaluate. So I have 7 times parentheses a, which is a negative 4, plus 4, plus 3 times b, which is 5, minus 8. Step by step, y'all. So I got 7 times parentheses, that's 0, plus 3 times 5 is 15, minus 8. 7 times 0 is 0, plus 15 minus 8. So this will equal 7. For b, I've got x over 2 plus y squared. Well, I'm going to go ahead and look at what they've given me here as far as my variable values for this particular expression so I can evaluate. So I've got x over 2, but x equals 1. So I've got 1 over 2, 1/2 plus y, which is 1/2 squared. Well, this is going to be 1/2 plus, remember that the 1/2 squared The exponent, remember, tells the reader how many times to multiply the base by itself. So this is going to be plus 1/2 times 1/2, which will equal 1/2 plus 1/4. Please remember how to multiply fractions. Numerator times numerator, denominator times denominator. Now 1/2 plus 1/4, I've got to find a common denominator. So this goes to a 4, this goes to a 2, and my answer is 3/4. Please remember that this became a 2 over 4 because I multiplied 2 over 2 to both the numerator and denominator using equivalent fractions to convert this fraction to a form that I can add to the 1/4. If you need a refresher on fraction operations, please check out one of my videos. Next, I've got 2 times x squared. X is 6, so I'm going to go parentheses x, which is 6 squared, minus parentheses y, which is -3 squared over 3. Be careful here, guys, especially with this one, y'all. Okay, ladies and gentlemen, you got to be careful here. All right, so I've got 2 times parentheses. 6 squared is 36, minus -3 in parentheses squared is a -3 times a -3, which is a +9. Why did it stay minus? Because of this guy right here. Okay, this minus the quantity of -3 squared. So all of this over 3. So I've got 2 times 27, 36 minus 9 is 27 divided by 3. Make your life easy. You could say to yourself 2 times 27 divided by 3, or 27 divided by 3, that's 9, times 2 is 18. All right. And last but not least, let's simplify each expression. And this, again, is example 3. So let's do it. When we're simplifying expression, we want to go ahead and perform all distributive properties. And then we want to combine like terms to simplify the expression. Okay, we want it in the most simplified form. So that means you have to apply all distributive properties and combine like terms. So let's do it. I have here 8x plus 3 times 2x is 6x, minus 15 minus 11x plus 4. Add like terms. 8x plus 6x is 14x, minus 11x is 3x. Negative 15 plus 4, they're the only constants. Constants are always like terms. Minus 11, I'm done. I have here y plus 4x, distribute, minus 6y plus 10x, distribute. What am I distributing? Please remember that's a -1 being multiplied to the sum or difference of 8 minus 4x. Don't forget that -1 being distributed. So -1 times 8 is -8. -1 times -4 is positive 4x. Let's add like terms. So I've got 1y minus 6y's, so it's -5y. Doesn't really matter alphabetically who comes first. Later we'll talk about standard form of expressions and equations. And when we put things in standard form, we're going from highest exponent to lowest. But for our intents and purposes right here, all of the coefficients, all of the terms have variables that are 1, so the alphabetical order does not matter. So I got y minus 6y, that's going to be -5y's. These are done. I've got 4x's plus 10x's, that's 14x's, plus another 4x's, that's 18x's. Done. Get rid of them, and that way you don't repeat, that way you don't stumble on the work. And then you have minus 8, which cannot be added to anything else. You're done. Okay, now I've got 1/3 that I have to distribute here. So 1/3 times 9 is 3x. Minus 1/3 times 6 is 2. Minus 2/5 times 20 is 40/5, which is 8. Now, I have a negative times a negative. So this is going to be plus 2/5 times 15x is 30x over 5, which is 6x. 3x plus 6x is 9x. -2 minus 8 is -10. My answer is 9x minus 10. Ding dong, the witch is gone. Last but not least, let's distribute that 4 to everything. So I've got 4c plus 12d. Remember, this is a -1 right here. So I have to distribute that -1 to everything. So that's minus 2d plus 3c, because please remember that a negative times a negative equals a positive, plus my 5c plus 6e. Well, 4c's plus 3c's are 7c's plus 5c's, that's 12c's, and I'm done with the c's. 12d minus 2d is 10d. I'm done with the d's, and I don't have any other e's, so I just place 6e here because I cannot combine that with any other like terms. And there you have it, y'all. Hope you learned a lot. Thank you so very much for watching, and y'all have a great day now. Bye-bye.